He actually did end the music earlier. Uh, Good day, everyone, and thank you for joining us for episode number 37 of Unsung Heroes of the Cloud, where today we are joined by Valentina Alto, who is a data and AI specialist at Microsoft, and we are going to be covering a very hot topic, namely Azure OpenAI, LangChain, and cognitive services. But before we jump into the tech, Valentina, welcome to the show. How are you?
I'm fine, thank you. What about you?
I am doing excellent. And I just wanted to let our audience know that I discovered you not because you're at Microsoft, but I discovered you through LinkedIn, where you shared an excellent post on LangChain and Azure OpenAI. But I think you've done some other stuff where you work out in the open with the community. Am I right?
Yes, correct. I write a lot of tech stuff, basically for fun, but also to share knowledge.
Okay. And what kind of things do you write? Blogs, books, poems? What all do you write?
Mainly blogs and articles, mainly on Medium, and I recently published my first book on generative AI via Pact Publishing.
Oh wow, amazing! How was the experience of writing a book?
Hard, but definitely a journey. So it's something that you need to practice, and I'm looking forward to the next one.
Okay, you're already looking forward to the next one. That is super cool.
Yeah.
And before we jump into OpenAI and LangChain here, we'd also love to know what you like to do for fun.
Oh, well, in my spare time, I love hiking and going to the mountains and also running. But the most funny thing is doing like Via Ferrata in the northern Italy mountains. That is a middle way between hiking and climbing.
Yeah, because with a Via Ferrata, I've never done one myself, but aren't you like hanging on the side of a mountain, just connected through one rope and having to get to the other side?
Actually, without a rope, but just with an equipment that is like in the adventure parks, the one for like children, where you have two equipment to like secure yourself to the mountains, but without a rope.
Without a rope, but you're
Without a
still,
rope.
if you fall, you're still connected to the mountain. You're not just
Yes,
falling
you're
down.
connected. You are
Okay.
in a not 100% secure way, but you are connected.
Okay. And then on the Via Ferrata, what is some of the coolest or most extreme things you've done?
Oh, I've done step that is basically vertical and flat. That is called like the death peck. So it sounds like it is actually. It was probably like the longest 20 minutes of my life. But the nice thing about Via Ferrata is that you cannot go back. So the only way is just go ahead. So you have no choice. And yes, that was
I
the
I l-
experience.
I love how you said the nice thing is you cannot go back. Like for me, the nice thing is if I'm hiking up a mountain and I'm done, I can turn around and go back. Like I think that's a nice option to have.
Yes, there is no exit strategy. So you really have to go ahead.
Okay, cool. That is very cool. And then when you mentioned hiking in the mountains in northern Italy, do you like do normal mountains? Do you go like to the high peaks? Like what's your strategy?
Oh, well, the highest was about 3,300 meters, but I would love to go higher, especially to Monte Rosa at the Capanna Margherita, that is around 4,300, if I remember correctly. Maybe
Wow,
600. Yeah.
4,300. Don't you suffer from like oxygen loss at that elevation?
Uh, I will never know if I don't try. So probably yes. Probably I will be so sick, but I have to try it to know it. So.
Okay, cool. But with that, why don't we jump over into some tech stuff? Because I discovered you with an article you wrote around OpenAI, LangChain, and Azure Cognitive Services, and what you wrote was simply amazing. And I think you
Thank you.
wrote. I just want to say, I think you wrote like 20 or 30 lines of code, and you had a full application that used OpenAI and cognitive services to scan a document and get text out of a receipt. I was flabbergasted. Like, how did you do that?
Correct. The thing is, nowadays, large language models are literally exploding. But the nice thing is that there are so many lightweight frameworks that make it so easy to integrate large language models within applications. One of these frameworks is LangChain, and this is the one I'm showing you today. And with LangChain, we not only are able to integrate large language models within applications, but also let them communicate and act with external sources like Azure Cognitive Service to make those agents multimodal, so that they receive not only text as input, but also other data format like images or video, for example. So maybe we can jump into the tech behind this amazing new world of large language models. And
let's do it.
Okay. So before jumping into the code, let me share with you which are the main components behind this architecture. So first of all, first ingredient, large language models. Large language models are deep learning artificial neural networks that have been trained on a huge and heterogeneous amount of data. This means that they are not task-specific, but rather generalistic, so that they can adapt themselves depending on user intent. And the very nice thing about large language models is that they mimic the way our brains work, meaning that they are made of neural connections, and their neural connections are extremely efficient and good at packing information. Very much more information with respect to our capability of packing information into our brains. So they can be seen as an extension of our brains, as AI tools that are able to plan, execute, and reason together with us. So those tools are amazing. However,
can I maybe, before you move on, I do have one question here, because one thing you put on the previous slide was that they are extremely efficient in packing knowledge in the network. Yeah. One thing that I've been thinking about, and as you read on these language models, there's this thing called retrieval augmented generation, where you don't trust the knowledge in the language model, but you use the language model to make the input or the input be more pretty. The question I have for you here is, can we actually trust the knowledge inside of the large language model, or how should we think about the knowledge in a large language model?
Well, this is a very tricky question in the sense that we can distinguish among two knowledge that the model has. The one is parametric, and it is the knowledge within the model, the one that you mentioned. The other one is non-parametric, and it is the one that we provide as knowledge base. Can we trust the parametric knowledge of the model? Well, consider that the model is a probabilistic model that completes the user prompt depending on the statistical probability on the training set where it was trained. The thing is, those models can hallucinate. So if they do not know the answer, for example, they can give wrong answers. Now, with the GPT-4, the technical architecture is preventing hallucination more than in the previous version of the model. However, it is still a limitation of the model. This is the reason why it is pivotal to keep human in the loops while developing applications with large language models, and also architecting prompt engineering techniques such that we do not let the model hallucinate. For example, grounding the model to a given knowledge base. So there are many techniques to address the topic of can we trust the large language models while producing answers.
Okay, thank you. That actually helped clarify a lot for me.
This is the question, so thanks for asking. Now, on top of large language models, we also need further tools for our application to be multimodal. Being multimodal means that we want our application, our intelligent agent, to be able to communicate with external tools to process further data on top of language. So those external tools will be Azure Cognitive Services. Cognitive Services are a set of pre-built AI models living within the Azure platform, Microsoft Public Cloud, and consumable via REST API. Also, Azure OpenAI is a cognitive service, meaning that Azure OpenAI models can be consumed via REST API. So what we will be building today is an agent that, thanks to the power of a large language model, will be able to understand which tools it needs in order to process user prompt, user requests. The final ingredient will be the AI orchestrator, the framework that we need in order to orchestrate our large language models within our application. For this purpose, we will use LangChain. It is not the only lightweight framework existing in the market. We also have a semantic kernel developed by Microsoft or iStack. But LangChain is probably the first one that came up in the market, and it's Python native, and I think it's amazing, but I'm not the only one. So basically, not only LangChain make it easier to orchestrate LLMs related components such as memory, plugins, agent, and so on, but it also comes with pre-built classes that already have a structure and a schema where LLMs can live and adapt. For example, if we think about prompt engineering, we know that there are several approaches that an agent or an application can follow while thinking upon a user request. One of these approach is called REACT, Reason and Act. Reason and Act is an approach that let the intelligent agent planning the actions that it needs to do in order to pursue the goals that it set according to users' input. It is a predefined framework. Now, LangChain provides pre-built agent with this framework embedded, meaning that you don't have to write code in order to set this framework. And this is exactly what we are going to do, so that we just need a few lines of code rather than a whole notebook of prompt engineering schemas.
And if I may ask a question here, sure. You mentioned that the React, I'd say, pattern is built into LangChain. If we were not to use LangChain, how would I build this myself? Would I have to write like multiple prompts that I then feed into GPT, or how should I think about that if I don't use LangChain?
Well, you should think about writing a meaningful meta prompt. The meta prompt is the system message that we give the model, and the model keeps this system message along the whole conversation with users. So it's something that it keeps embedded. We should write a meaningful meta prompt where we explain how the model should reason, how we want the model to reason upon users' request. So it's something that can be definitely achieved also without LangChain pre-built classes. But having that pre-built make it easier to develop this kind of React approach agents.
Okay, thank you.
To you for the question. So these are the three ingredients that we are going to use. As I said, we are going to build an agent. An agent can be seen as an intelligent application powered by a large language models that can also execute actions. And when I mean executing actions, I refer to the call or the usage that this agent is able to do to external tools. Those external tools will be Azure Cognitive Services. And this is the high-level architecture of our application. There will be a user that will ask a question to the agent that, powered by a large language models, in this case a GPT-3 model living within Azure OpenAI. Well, upon the request, the agent will be able, thanks to the React approach, to plan a set of actions and call the Azure Cognitive Services to execute whatever it's not able to do on its own. For example, processing images or doing OCR. Because the thing is, large language models are incredible, but they miss some capabilities that are not achievable without external tools. They need the power to execute. To do so, we can give those tools to them so that they can reach like a full coverage of data source and format. Okay, I think that we can now jump to the code. So
yes.
Let me share my notebook. Okay.
So, and just so we can make this clear for everyone in the audience, what are we looking at here?
Here we are looking at Visual Studio Notebook with a Python interpreter. And what I'm going to do is building an intelligent agent using LangChain. LangChain is a library that can be imported directly via pip install LangChain. That is the way you install Python libraries. And once you install LangChain, you can import modules and classes from the main root of LangChain and use them to build powerful agents. LangChain also comes with a series of connectors towards large language models. One of these connectors is towards Azure OpenAI. And we're going to use Azure OpenAI Models API as a large language model, so as the brain of our application. More specifically, we will use the DaVinci 003, that is the GPT-3.
Okay, cool. Let's see it.
Okay, fantastic. So the first thing that we are going to do is setting our environmental variables. Here we need two services in Azure. One, Azure OpenAI instance, where we will create a deployment with a model on top of the deployment. In my case, again, I deployed a GPT-3. And the other instance that we need is a cognitive service multi-service instance. The multi-service instance is very useful because with just one API, it allows you to have several cognitive service available just with one API call. And we will see the magic here because with one API, LangChain, depending on our request, will be able to understand which tool it needs. So we are not going to tell the model, I will need you to use form recognizer. It will understand by its own. So you will have a set of tools and you will smartly decide which tool to use depending on our request. So as you can see here, I just iterated over my toolkit, and these are the cognitive services that are available for me. We are talking about the form recognizer for OCR, the speech to text and text to speech that just convert speech to text and vice versa, and the image analysis. That is basically a model that is able to extract metadata from an image and analyze it. Now, let's initialize our agent. So the first thing I'm done is importing the Azure OpenAI class from LangChain in order to initialize the main component of my agent, the large language model. As I say, as you can see here, I passed two parameters to the class that are the deployment name and the model name. In my case, I named the deployment as the model name just to make it easier to remember. Remember that I previously set the environmental variables here. So the LLM class is reading my Azure OpenAI API key, base endpoint, and region. Okay, I can also try my LLM here. Like I still didn't embed it in an agent, but I can use it as an endpoint. And I asked it to tell me a joke. Now the humor is debatable, but it worked. So
I'll tell you, this is my type of humor.
Fantastic. So you can have a conversation with the DaVinci 003 if you like. And this is just to try whether the connection with Azure OpenAI endpoint works, and it does. So we can go ahead. Now we can initialize the agent. The agent will be the application, our artifact that will be able to execute our intent. So as you can see here, I imported two functions from LangChain agents that are the initialization and the agent type. And here, with just a few lines of codes, I'm able to configure my agents. Let's go deeper into that. First of all, I want to provide a perimeter to my agent, saying that, look, you can only use those tools. I don't want the agent to be, free globally. I want it to be grounded to a set of tools. And those tools are the one that I already initialized here with the Cognitive Service Toolkit. This is another nice thing about LangChain. LangChain already provides the pre-built toolkit towards Azure Cognitive Services, so you don't have to write the connection on your own. Then we need the large language model, and we already tried it. We also saw that it has a very nice sense of humor, so it works. Then we are going to set the type of the agent. And as you can see here, this is a very specific type of agent that has a zero-shot React description. So it is a React approach agent with zero shot. Zero shot means that we are not providing the model with few examples to learn on. We are just providing the model with a prompt, with a request. And the nice thing about large language models is that they are very nice at working also without examples or with just few shot examples, but they do not need a lot of data to train on to be performing.
And if I may, just one of the nice things that I see in here, and correct me if I'm wrong, but what I'm seeing is we are now using a fully Azure specific example where our toolkit is Azure Cognitive Services, our LLM is the Azure OpenAI service. But what I'm seeing here from LangChain is that this is sort of abstracted away. And if we were to use another LLM or we were to use another toolkit, we could use exactly the same code and maybe plug out the Azure OpenAI model and insert OpenAI directly, or maybe something from Hugging Face, and this code should remain functional. Is that sort of right?
100% correct. LangChain made it extremely easy, and it has interoperability with a lot of external sources. The list of connections is growing every day. The Azure Cognitive Service Toolkit is one of the latest release, but it's growing literally every day. And you mentioned the Hugging Face Hub, but also the OpenAI API. So not on Azure, but on the OpenAI public playground. But also BERT, T5. So a lot of open source models can be integrated within LangChain, as well as toolkits.
Okay, wonderful. Love it.
Me too. That's why I love LangChain. So let's start. By the way, the work is done. I mean, we finished. So we have our agent and our application is ready. Now we have to test it, but the implementation is done. So literally, few lines of code. So let's do some experiment here. Oh, by the way, here I kept verbose true to show you the thought process of the model, which I believe is insane in the sense that it's fascinating to see how a large language model thinks.
Okay, I'm curious.
Yeah, let's see if it thinks like correctly, hopefully. So first thing, I have here a beautiful picture of a dog, a Weinheimer, if I pronounce it correctly, admiring at the landscape of a lake within mountains, which I love as landscape. And what I asked the model is generate a funny story targeted to children about the following image. So I have an image and I want to generate a story for, I don't know, some children in an elementary school. So I gave it a target and I gave it a picture. Let's see what the model does. So first of all, it takes the action that it needs to perform, and it immediately understood that it will need to use the cognitive service for images. Okay? And this is the input that it will use. This is the picture that I passed it as a parameter. Then it will observe the caption of the image generated by the cognitive service. It understood that there is a dog sitting on a grass by a lake. The object is a Weimaraner, I don't know the pronunciation, but I checked on Google and it's actually the proper dog. So, so I can confirm that. And it also captured the tags that the image service read from the image. And then the thought of the model is that now it can use the object and tags to create a story. And we have the story. That is this one. Now, I don't know if we want to read it.
We don't have to go through the whole story, but it's indeed impressive that with very, well, you essentially wrote one line of code where you provided it the prompt and the image, and all the rest just happened. So you didn't have to do any of the image analysis. You didn't have to do any of the advanced prompting to pass along the tags. You just provided the image and everything happened under the covers. That's pretty
Exactly.
amazing.
Exactly. And consider that all this thought process is thanks to the React approach that is already embedded in the agent type within LangChain.
Yeah.
So
And
this is truly powerful.
one question I have here though is when I look at your verbose output here, the first action was already calling the image analysis service. Is that something that I assume that's LangChain that knew to take this action because it saw that there was a picture as part of the input, or am I overthinking it? And is this also provided by the LLM?
Well, I think that the answer lies in the next example,
Okay.
because we also have another example with an image, but because of the request that I gave to the model, the model, or better, the agent, understood that in that case, the image analyzer wouldn't have been the proper tool to use. So
Okay. Now
let's
I'm even
go.
more curious.
Let's go to the next one. As you can see, still an image. In this case, it's a sample invoice, but it's an image, so the format is an image.
Okay.
And here, I'm asking my agent to give me the due date of the following invoice. And here, it immediately understands that it has to use form recognizer and not image analyzer, even though the data format is the same. So it's
So is this then, and sorry for my continuous questions, but is this then sending your first prompt to the LLM first to get back which model it should run, or is this all captured within LangChain? Like, who makes the decision on which cognitive service to call?
the LLM. The LLM,
The LLM.
that is the brain, the engine, the thinking engine behind the agent.
Okay.
So the thinking engine understands the user intent, set the goals to achieve the intent, and calls the tools needed to achieve the goals.
Okay.
And that is when I mentioned the fact that those LLMs can be seen as an extension of our brain, I meant exactly this. It's not just generate me a fun story. It's more help me thinking, help me doing common sense reasoning.
Yeah.
This is what the model does in the backend. Okay, so in this case, we are calling the model is calling the form recognizer to extract the elements of our invoice. And form recognizer, as I said before, is an OCR tool that is able to capture handwritten materials from documents, and it comes with pre-built templates that can be applied to standard documents like invoice, for example. And here, as you can see, the form recognizer extracted a lot of material from the invoice, and then it's able to return the correct answer. So this is, imagine you have tons of invoice or contracts or documents where you just need a very small piece of information. And these tools can be used as a support for navigating the heterogeneous amount of information that you might have within your enterprise.
Yeah, this is pretty cool.
Yeah.
Really, really nice.
Yeah, I agree with you. And the last example that I wanted to show is how this agent can also use more than one tool at once if we have a multimodal ask for the agent. So here, in this case, and by the way, I would need that so much in my fridge. And I have this I have this picture that, well, this is not my fridge, but I have this picture, and I want my model to describe me what I might cook with these ingredients. I have to say very poor ingredients, but I mean, not my fridge. So, and but I want to ask the model to read it aloud for me, because I don't know, I want to read it aloud. So I will invoke two models, one for image recognition and the other one for text-to-speech.
Yes.
And here I can do so by specifying the true output file, and then it will call both the cognitive service image analysis. It will generate the response as it did for the story of the dog. And then we would also call the cognitive service text-to-speech to produce a file that will read aloud my recipe. I don't know if we can
You can make a vegetable omelette with the ingredients in the picture.
I could hear that.
Okay, fantastic. So I can make a vegetable omelette with the ingredients in the picture. So, but still, the agent was able to discriminate among tools and decide which one to use depending on my intent. And I think that this is extremely powerful, especially now that application development and software development is embracing a new wave of of components. Large language models didn't exist in the context of applications 6 months ago.
Yeah, this is incredibly impressive because I think the large language models themselves are very capable because you just pass it some inputs around. Here it is, a refrigerator full of vegetables and eggs, and it comes up with a dish that is impressive by itself. But then chaining this together with image analysis and chaining this together with text to speech and potentially some other cognitive service models it's just insane what's possible here. And we're talking about in a time frame of like 6 months from when this all started. Impressive.
Yes, that's impressive. I agree. And the fact that also the list of tools and integrations within these frameworks is expanding day by day let us hope that those agents will be easily integrated with so many external tools and also with structured data. Because in LangChain, for example, you can also build agents that talk with structured data like CSV files or Azure SQL database. So I think it's extremely powerful. And again, LangChain is not the only tool available in the market today. There are so many tools. I think it depends basically on the developer's preference. But from an agnostic point of view, having an AI orchestrator while developing LLM-powered applications is a must. So I think that LangChain and these tools are paving the way to a new era of software development.
Okay, so if I understood what you said correctly is you're not recommending anybody to use LangChain per se, but you are recommending people to think about an orchestrator, let that be LangChain or Microsoft Semantic Kernel or Llama Index or whatever orchestrator they use, but you still recommend them to use the orchestrator because that helps with doing a lot of, or abstracting away some of the complexity of building all of the change and the reasoning.
Exactly, because at the end of the day, LLM's components are the same: memory, plugins, chains, prompts. So those components just need to be arranged in a nice way, let's say. So LangChain helps, semantic kernel helps, but in general, what we need within our application stack is an AI orchestrator.
Okay, cool. So maybe, but before we end up here, I have one final question for you, and it might be a really hard one, but
oh no,
what happened in the past 6 months has blown me away. Where will we be 6 months from now?
Oh, wow, that's a hard question. Well, what I can see is, again, a huge development in the field of plugins. So more and more connections toward the external world to give LLMs the power to execute actions. And I'm also seeing new ways of developing large language models, or more generally speaking, large foundation models. One example is Orca, the model announced by Microsoft a couple of weeks ago, I think. And the trend that is occurring now is like working rather on the training dataset than on the model architecture to make models lighter, so with less parameters, putting more attention in the quality of the dataset. And in the case of Orca, the incredible thing is that Orca has been trained not on text corpora, but rather on the reasoning process of the GPT-4. So that basically the training dataset of Orca is mainly made of thought process rather than simple and plain text. I don't know where it will bring, but from the presentation that was publicly released, it sounds amazing. It's like magic. The thing is, we will have lighter models with maybe better performance, or at least as good as the GPT-4 or extremely large models.
Okay, interesting. And do you also think that we will have more vertically aligned models, like a vertically aligned model for insurance, financial services, maybe one for healthcare? Or do you think we will still have very general models like GPT-4?
I think that both ways will be valid in the future. Meaning that as long as now that the architecture of large language models is being validated more and more, probably many companies and industries will start building very vertical LLMs or LFMs on their knowledge base. So definitely, yes, I think that some in the finance industry, some companies are already doing that, but I think also that the real power of foundation models is the fact that they are general and adaptable. So I think that the trend of a general purpose foundation model will keep existing in the next future.
Okay, cool. I want to thank you so much for coming on. I had a blast discussing this. I know that OpenAI is all the hot craze, but I wasn't expecting this, what you showed me, because this is simply mind-blowing. And with that, Valentina, I want to thank you, but I also want to thank all of the people who watched up to this point, and we'll see you again in a couple of weeks. Thanks, everyone.
Thanks a lot. Bye.